Okay, number 10, we want to decide whether the ordered pair is a solution to the system. We have two ordered pairs. This one, instead of plugging in both points and seeing if both sides come out equal, I'm just going to plug in one number, whichever one is easier, and solve for the other one. So in the first ordered pair, I'm going to use negative 2, 0. I'm just going to plug in a 0 for the y. This is x, y, remember, so I'm going to plug a 0 for y and make sure x comes out to be 2. So I have a negative 2 equals x minus 6y. If I plug a 0, I got negative 2 equals x minus 6 times 0. That term is going to get eliminated, so I got x equals negative 2. The first equation checks out. All right, so I'm going to try the second equation. So I got 8x minus y equals 16. Plug in the 0 for y. 8x minus 0 equals 16. 8x equals 16 divided by 8. And we get x equals 2, which is not the same. We need x to be negative 2. Let's scoot over. The second order pair, one half and 5/12. Okay, so it's going to be easier for me to work with a half. So I'm going to plug in a half for x. So I got negative 2 equals x, which is 1/2 minus 6y. All right, so I got a fraction. I want to get rid of it. I'm going to multiply everything by 2. 2 times negative 2, negative 4. 2 times a half, the 2 is going to cancel, leaving me with 1. 2 times 6, negative 12y. If I subtract 1, this leaves me with negative 5 equals negative 12. Y divided by negative 12. And we get negative over negative is a positive, so I get 5 over 12 equals y. So this one matches because 5 over 12. And then let's try the third or the second equation, which is 8x minus y equals 16. All right, I'm plugging in a half again for x. 8 times a half minus y equals 16. So half of 8 is 4 minus y equals 16. And then if I subtract 4, I get negative y equals 12. And y needs to be positive, so divide by negative 1. And we get y equals negative 12, which is not 12 over 5. So it looks like neither of these ordered pairs is a solution to the system of equations.